welcome back to Well, That's Interesting, the You Better Explain This One to Me edition. Today is episode 179. Some plants are evolving to have less sex, and reindeer can sleep while they eat. My friends, today is all about the private lives of creatures great and small. And we humans, I think we humans are a bit, let's say, self-centered. I'm sure you could agree. So may I be so bold as to say there's a lot going on around us we are completely blind to as we narcissistically burn. Okay, that was a lot. I'm sorry that last comment was a bit of a bummer, but I can't help it. It's thanks to the study we're going to dive into in the first half of the show. We're going to take a hop, skip, and a jump over to France, the nation of amour, where researchers asked a very good question that deserved an answer. As the world's population of bees and other pollinators steadily declines, would plants that depend on those pollinators for fertilization find another way to reproduce? Now, if you're a longtime listener of this show, you know that nature has many tricks up its sleeve to survive drastic environments, those created by our clusterfuckery or even nature herself. For example, way the fuck back in between 052, we took a magical trip to Aquario di Cala Gionone. Gionone? I nailed it. On the island of Sardinia, where a single female smoothhound shark was born to a mother that spent the last 10 years sharing a tank with one other female and no males. Unfortunately, no, she was not the daughter of two female sharks. Asperia, as she was called, was most likely created by another radical reproductive process called parthenogenesis, in which a female can produce an embryo without fertilizing an egg with sperm. Also, way the fuck back in between 057, we talked about three-eyed crustaceans in Arizona called triops. Totally a real thing. And these badasses evolved during the Devonian period, which was a staggering 419 million to 359 million years ago, which means they have seen and survived some shit. They are still around today, and that's thanks in part to the same process, parthenogenesis. When times get tough, like a severe drought or fucking asteroids, triops that are female can whip out the asexual reproduction card. This process also exists in plants, but has another term that I think is spot on and something we could all relate to. In plants, it's called selfing. Yeah. Yes, I heard you. I heard you say it and laugh. It's selfing. That's right. Let's say it together. Selfing. Excellent. Well, thanks to the decline of pollinators in France, a team of researchers has shown for the past several decades there has been an increase in selfing. Now, how in the holy hell can you tell which wild plants are essentially clones over decades? Yeah, it sounds crazy, but we are going to dive into the ingenious study that found a way to do this and its methods, and we will get to a conclusion that is rather shocking. Then after the break, we are heading to the top of the world, where neuroscientist Melanie Furr and chronobiologist Sarah Meyer asked a weirder question. Arctic reindeer, okay? You heard me. Arctic reindeer eat around the clock during the summer. But these gorgeous creatures are also ruminants, like our friends cattle, sheep, antelope, deer, and giraffe. Now, what the fuck is a ruminant? Well, I'm going to explain that lovely word and its process in detail later on, but for now, let's just say these cuties spend a considerable amount of time chewing on regurgitated food. We've all seen them do this, and it occupies so much of their day that Melanie and Sarah were like, when the fuck do they have time to sleep amid all this cud chewing? As one would naturally ask. Well, it turns out the answer is pretty goddamn cool, and I'm a little jealous. I'm a little jealous of it. How Melanie and Sarah were able to discover, how they were able to... Okay, the answer is pretty crazy, and we will get into their study. I cannot wait. In the meantime, I'm Jill Chacha, and if this is your first time listening, welcome to the flock, my snowy business goose. To begin, we're booking a first-class ticket to France because we deserve it, and we also need to meet up with Pierre-Olivier Chepteau, an evolutionary ecologist, and Samson Okoka-Pidol, a doctoral researcher over at the French National Center for Scientific Research, located just a smidge southwest of the Arc de Triomphe. Now, a few fun facts about this here center. No big deal, but it is the largest fundamental science agency in Europe. In 2016, it employed over 31,000 people, including tenured researchers, engineers, technical staff, and contractual workers, whose number one goal is to study, quote, the living world, matter, the universe, and the functioning of human societies in order to meet the major challenges of today and tomorrow, end quote. Goddamn, also no big deal. And that was from the Scientific Research Center's website, cnrs.fr. Goddamn. Our next fun fact is its location. And yes, CNRS is in gay Paris, but Paris is also located in what's called the Parisian Basin. Now, for my fellow geographically challenged Americans who may be wondering where all of this is exactly, don't worry, I've got you. Please imagine France. Thank you. Now point to the center. Fabulous. Now move your finger a bit north. Perfect. There is Paris. Now move your finger all the way up until you hit the coastline along the English Channel. All of that is the Parisian Basin, and it's one of the major geological regions of the country, having developed since the Triassic. She is ancient and home to many an ancient species. Now, when you put fun fact number 1 and fun fact number 2 together, you get Pierre and Samson, passionate researchers who want to investigate the field pansy. Yes, the field pansy. Now, stick with me. Stick with me here. This gorgeous, delicate plant whose flower is made of small, bulbous white petals, with some white petals blotted with yellow near the stamen and or pistil, which are the literal sexy parts of the flower. These plants are abundant, like all caps abundant. So much so they're like found on roadsides across Europe. Barf. They are everywhere, including the Parisian Basin. But what is no longer common are the pollinators. According to Phoebe Watson of TheGuardian.com, toxic pesticides, climate change, and vanishing habitats have driven down populations of bees and other helpful creatures to such an extent, quote, one study on German nature reserves found that from 1989 to 2016, the overall weight of insects caught in traps for study fell by 75%. End quote. What the fuck? 75%? That is a big dent in biomass. And that study, by the way, this hurts, but that study took place in protected areas. So can you imagine the number in an unprotected one? These were the concerns of Pierre and Samson. They asked, with pollinators slowly disappearing, will plants, like the common field pansy, find alternate ways to reproduce? So, my bedazzled business goose, you may be asking, how? How are we even going to go about tracking alternative hanky-panky? That is a great question. Turns out, Pierre and Samson aren't the only eco-super nerds around. They come from a long line of them. For you see, back in the early 1990s and early 2000s, researchers from the Conservatoire Botanique National de that place and the Conservatoire Botanique National du Bassin Parisien, from these two places, they collected seeds from over 100 field pansy plants from the Parisian Basin. And again, that occurred between the 1990s and early 2000s. Okay, that's column A. Pierre and Samson got to thinking, and the experiment they came up with was a simple but profound one. We'll grow these plants from the past, the ones in column A, and we'll compare them to plants grown from the seeds of pansies in the Parisian Basin today, in column B. According to their study, titled Ongoing Convergent Evolution of a Selfing Syndrome Threatens Plant-Pollinator Interactions. Quote, the second sampling was performed in exactly the same locations, in an area that overlapped the ancestral sampling area as much as possible, in February 2021, by randomly sampling 40 or more seedlings. End quote. Okay, so my colorful friends, after growing the new and old seeds side by side in a lab under identical conditions, what did they find? Drumroll, please. Thank you in the back. Okay. Hold on to your botanical cheeks. They discovered that selfing had increased 27% since the 1990s, and the speed of this change occurred in just 20 generations. 27%. Over 20 generations. If that sounds like a lot and mighty quick to you, you're right. It truly very much is. Quote, our study shows that pansies are evolving to give up on their pollinators, said Pierre to The Guardian. They are evolving towards self-pollination, where each plant reproduces with itself, which works in the short term but may well limit their capacity to adapt to future environmental changes. End quote. Well, Sampson added to this fabulous news as well by saying, quote, our results show that the ancient interactions linking pansies to their pollinators are disappearing fast. End quote. So, my neighbor's dog is appalled, as you can hear. And here we are, my shocked business goose. I know what you're thinking. I think you're thinking, Jesus, thanks, Jill, this is a bummer. And what exactly is changing about these plants if they're resorting to some sweet, sweet self-love instead? Well, I'm so glad you asked and phrased it that way. Here's some kind of good news. Okay, they found no changes between the populations in leaf size or total size of the plant. Size, totally the same. However, here's the bad news. And don't worry, there's even more worse news to come. We'll get to that. First, this. The recent field pansies, the ones from 2021, shrank their flowers by a whole ass 10% and reduced their nectar production by an even larger 20%. Let that sink in for a minute. They reduced their nectar by 20%. Okay, now that might lead you to think, Jesus Christ, Jill, you're killing me. This sounds like they're reeling it in, and bees won't be able to find and nectar and feed and whatnot. Yeah. Yes, my bumbly business goose, you are right once more, and you're not alone. Pierre and Sampson had the same thought, so they whipped up a second experiment. Get this. According to Carl Zimmer of the New York Times, the researchers suspected that these changes made the new field pansies less attractive to bumblebees. To test that idea, they placed bumblebee hives inside enclosures with old and new field pansies. Sure enough, the bees paid more visits to the old plants than to the new ones. End quote. So, my hungry lovelies, just like you mentioned, this reduction in nectar could affect our pollinating friends who are already struggling. Now, as to how they could be affected and why these plants are reducing their load, so to speak, Pierre explained to the Times that the cost of producing nectar and big, attractive flowers may have become a burden on the plants. Instead of investing energy into luring pollinators, it's possible field pansies are having more success by directing it to growth and resisting diseases. It's also possible many other flowers face the same challenge to their survival, and they may also be evolving in the same direction. There's no reason to think that other plants have not evolved. End quote. So, my adorable business goose, if selfing is the go-to for not only the common pansy, but other species as well, the situation with bees, bats, butterflies, and other pollinators is compounded, to say the least. If plants make less nectar, creatures will go hungry, driving down populations even more, and making sexual reproduction even less rewarding for the plants. This short-term solution seems to be working for the field pansies. They're still here, they're healthy. It's almost like they're waiting it out and waiting for humans to get their act together to improve this worldwide problem. Or maybe they're waiting for our demise, and I get it. But who is to say when either of those happen? And that could be extremely dangerous for our budding amigos. Pierre was on a roll in his interview with The Times and raised this red flag. If some plants eventually give up on sexual reproduction altogether, it's unlikely they'll be able to regain that ability again. In the long term, the genetic limitations of selfing could put plants at risk of extinction. End quote. Jesus Christ, Pierre. Well, this is terrible fucking stuff. So that's what I meant in the beginning, in the intro. That's it's a bummer. It's a bummer, and I didn't want to end on a doom and gloom note. So I did a Google, and you know what? Some plants are just too inherently slutty for this kind of lifestyle change. Please, head on over to our social media stuffs and tap on today's post. Swipe through until you see a gorgeous photo of a hummingbird feeding it what's called a foxglove. I'll give you a sec. Now, what you're looking at, I'm sure you're thinking, okay, this relationship, this has to be as old as time, right? Well, no. The foxglove originally evolved to be pollinated by bumblebees in Europe. And those pollinators love open-faced flowers, if you will, like the pansy. Now get this. 200 years ago, foxgloves were introduced to Costa Rica and Colombia. And they have since changed the shape of their flowers so they could be pollinated by hummingbirds. In only 200 years. That's a great fucking sign. Sasha Bishop, an evolutionary biologist at the University of Michigan, performed a study on morning glories in the southern United States between 2003 and 2012, and she and her team found that their flowers became bigger, not smaller, perhaps as a way to outcompete other plants and attract a shrinking number of pollinators. So, what is gonna happen? Which plants will do what? Like, who goes what direction? It's the fuck if I know. We don't know. And what a time to be alive. After the break, do you consider yourself a busy person? What a segue. Well, I think we all are, and it turns out even Arctic reindeer are up to their eyeballs in to-do lists. Now, to be fair, their lists mostly revolve around eating, but moss, herbs, ferns, grasses, and the shoots and leaves of shrubs and trees, but hey, it's a lot. And thanks to their digestive system, they need to chew, all caps, constantly. So, when do they sleep? We're going to find out, and it's wild. Stay tuned.
Wherever there are rules, there is someone going astray. Sex, sleaze, and shady power moves. It's a story as old as time. I'm Kiki Anderson. As a comedian and former journalist, not a lot surprises me anymore. But as we stumble through a doomed world and a digital hellscape, it can drive you crazy trying to make sense of what is and isn't kosher. On Indecent, I'm peeling at the wallpaper of polite society to understand the why and the who behind our taboos. Come along for the ride as I explore everything from porn to politics, tech, and religion.
If you can't get through the day without, rubbing one out in the bathroom stall at the office, you got a problem.
There's a big community around people trying to trade tips and tricks on how to suck your own and just many different pages of threads about this. And then people kind of create friendships through this.
Subscribe, rate, and review Indecent with Kiki Anderson on Apple Podcasts, Spotify, Stitcher, and wherever else you get your podcasts. Also go to ncpodcast.com/indecent to learn more. Indecent with Kiki Anderson, where NSFW meets LMAO.
Hi, fancy folks. Welcome to Lux Sci, where we make science fun, approachable, and most of all, fancy. I'm Dr. Lex, former microbiologist, current global health consultant and enthusiast of all the finer things in life. I'm often joined here by my husband, electrical engineer, inventor, and our audio engineer, Dr. Demos. In this podcast, we take listeners on a journey into the microscopic worlds of luxury items and unravel the fascinating intersection of science and opulence. From how bubbles form in champagne, to the molecular forces that harden clay in a kiln, to the amount of thrust needed to send a rocket to space. No luxurious topic is safe from our insatiable curiosity. We're on a mission to demystify science and show how it drives the world around us. No PhD or lab coat required. So if you've ever wondered how science and luxury seamlessly intertwine, join us as we uncover untold stories, hidden marvels, and the inner workings of scientific discovery and sophistication. Along the way, we'll also chat with amazing scientists and artisans, so subscribe now and let the exploration begin.
So this is History Uncovered, and I'm Kalina.
And I'm Austin. We are the co-hosts of the show.
History Uncovered is a podcast presented by All That's Interesting, where we both are writers. We cover all sorts of topics: true crime, unsolved mysteries, history, folklore, the paranormal, you name it.
We've been doing this now for more than 100 episodes, covering a wide range of topics, and probably something that's bound to be interesting for everyone out there.
Absolutely. And in addition to our normal episodes, we also do a history happy hour about the recent news in the world of history and archaeology, which we cover daily on the site, as well as important historical anniversaries.
We also have done some special series. We've done one on the Titanic, doing one on Jack the Ripper, done one about some famous UFO sightings. So if all of that sounds like something that might be interesting to you, and you like having a good time, learning new things, and maybe laughing or just groaning at some bad puns, check out History Uncovered everywhere you get your podcasts.
And we're back. We are so back. And my friends, I'm going to ask you to shrink yourself down, small enough so that you can be swallowed by an elegant female Eurasian tundra reindeer. Yes, please, stick with me. Stick with me. We need to take a little tour of their innards, specifically their digestive system, so we can understand why neuroscientist Melanie Furr and chronobiologist Sarah Meyer created the study we will also be diving into. To begin, let's start with a few fun facts about the outside and behavior of the Eurasian tundra reindeer, also known as the Arctic reindeer. Well, these babies can be found throughout Greenland, Denmark, Norway, Sweden, Russia, Alaska, and Canada. They migrate between tundra and forest in huge herds numbering up to 500,000 in an annual cycle covering as much as 5,000 kilometers or 3,000 miles. Males can stand more than 1.2 meters or about 4 feet at the shoulder and exceed 250 kilos or 550 pounds. Females are a smidge smaller, just a smidge, and they both have antlers that can grow up to 44 points and 1.4 meters or 4.5 feet long. Jesus. In winter, they head to the forests, and in spring to the tundra, and in fall they mass again to return to the forests. All of this moving back and forth is, you guessed it, to find food. We're talking moss, herbs, ferns, grasses, shoots, leaves, and mushrooms. Sounds fucking delicious. This is in late summer. Lichens, a plant-like green smear thing, is eaten in winter, which they reach by digging craters in the snow. It's adorable. And please, put a pin in lichens for a moment. Now, speaking of food, here we are. Let's take a gander inside our Arctic reindeer. Here we go. These animals have a lot going on when it comes to their digestive system. They are ruminants. Okay, what in the holy hell does that mean? Okay, don't worry, I've got you. According to mun.ca, quote, ruminants are unable to digest plant material directly because they lack enzymes to break down cellulose in the cell walls. Digestion in ruminants occurs sequentially in a 4-chambered stomach. Plant material is initially taken into the rumen, where it is processed mechanically and exposed to bacteria that could break down cellulose. End quote. Okay, that's the first step. Prepare yourself. Next is the reticulum. And this allows the animal to regurgitate and reprocess that particulate matter. That's all the chewing you see, like cows do, for example. The fancy term for it is called ruminating. Reindeer do this too. So please bust out your pins and stick a pin in this. The cud that was in their mouth is now, quote, finely divided food that is passed to the omasum for further mechanical processing. This mass is finally passed to the true stomach, the abomasum, the fourth chamber where the digestive enzyme lysozyme breaks down the bacteria so as to release nutrients, end quote. Lysozyme. I think I nailed that as well. I'm just on fire. So there you have it. More than you ever wanted to know about the digestive process of these kinds of animals. You may now exit the Arctic reindeer from either end you prefer. Great. Clean yourself off, and let's head on over to the animal facility of UiT, the Arctic University of Norway, at Tromsø. It was here, aptly named Melanie Furr, Sarah Meyer, and their colleagues had an inquisitive question. Between all of this migration, this constant foraging and chewing, when the fuck do they sleep? Yeah, for real. Well, as reported by ScienceNews.org, neuroscientist and study co-author Gabby Wagner notes that the indigenous reindeer herders have a concept that roughly translates to pasture peace. Reindeer need time and space to be quiet and to have peace to ruminate. That's right, dog. So, my non-antlered business goose, maybe, just maybe, that peaceful time, while they are chewing is when they are actually catching some Z's. I know, it's shocking. So, how do you even go about testing this? Well, here's what Melanie, Sarah, and the gang did. Please head on over to our social media stuffs and tap on today's post. Swipe past the handy graphic of a see-through cow, which will show you all the steps of a ruminant's stomach, that whole fucking situation. Pass through it, and eventually you will see a photo of 4 female Eurasian tundra reindeer in a pen. Now, each is in their own little individual stall, and they were trained to tolerate it by being fed their version of sugar, lichens. These treats, quote, which are like candy to them, end quote, said Sarah to ScienceNews.org. So, the gang also shaved off a portion of fur and applied non-invasive electrodes on their skin. The electrodes were hooked up to an EEG looking for brainwaves that appear during non-REM sleep, which is a deep restorative phase. So, what in the hell did they find? Drumroll, please. Thank you. Well, that restorative sleep phase showed up while they were ruminating, y'all. Yes, while they were chewing, they were asleep. And it was a bit tricky to figure it out, but they nailed it. Quote, these waves appeared when the reindeer were chewing cud, though the chewing motion itself made it hard to say whether the signal was identical to that of a regular sleep session. We couldn't go into detail by looking only at the brainwaves because we have this chewing in there that disturbs it a bit, said the fur to Science News. Okay, so don't worry, my friends. Not only did they have these brainwaves, there were other signs pointing to sleep while chewing. Again, totally jealous. The reindeer were calm, often with their eyes closed. Quote, they were in a very relaxed state that resembled the body position of non-REM sleep, the fur added. The 4 ladies were also harder to disturb while ruminating. For example, Rustling from a neighbor was less likely to get a look from a chewing reindeer. So, all in all, combining all of this evidence, yes, my sleepy business goose, this study demonstrates that reindeer are able to sleep while eating, while ruminating, while chewing. Give them a round of applause. If I could eat a burrito while I'm sleeping, I would. I'm not ashamed. Okay, I'm moving on. So it turns out the indigenous were right all along, so no surprise there. This pasture piece is a real thing. Maybe we should listen to them more often. Yeah. Thank you for listening, rating, subscribing, telling your friends that plants are just dipping out. They're less like down. They're not swiping right anymore, or left, or whatever the fuck it is. They're just not swiping at all. They're not even downloading apps. Yes, exactly. I hope this mic can pick up this dog next door. Oh my God. Thank you to my co-host. Thank you, dog. Please tell your friends that reindeer can sleep while they eat or eat while they sleep. Talents. And an Arctic-sized hug to the folks over at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you love the other podcasts in this family, and please, stay interesting.